So, two concepts here. Firstly is a tangent. And what I'd really like you to write in the space underneath is a note that if you have a curve and a tangent hitting that curve, then at this point, they share, so both the original curve and the tangent share a common xy point, and they also share a slope, or gradient. So they also share gradient. And what this means is that the first derivative here, f dash x, of this particular point, is going to equal the slope of the gradient, and if we're looking at y equals mx plus c linear. Now, there are two ways to find the equation of this tangent line. There is the way the book suggests with a formula, and then there is a alternative way. And I think it's worth being aware of both. So, the formula is just this. Y is equal to f dash a, x take a, plus f of a. And you find the different components, you plug it in, and it spits out an answer. It'll get you the answer to the tangent equation, but it doesn't get the answer with a lot of understanding. Yeah?
What's f of a?
Good question. So, a is the point of interest. So in our example here, we have a square root function, which will look something like this. And then at the point 2, 3, here a is 2. It's the x point of interest. At the point 2, 3, we want the equation of a tangent. So at some point here, which is the point 2, 3, there is a tangent, and we want the equation of that line. And that's what we're hunting. And we're going to do it two different ways. Firstly, we're going to use the formula, which is pretty nice. Second way, we're just going to hunt mx plus c using our various knowledges. But we'll do this first. So, the formula is pretty formulaic, and you'll have seen it last year, I'm hoping. We need a bunch of stuff. A good place to start is f dash x. So if you want f dash x, in this case here, f dash x is going to be a half x squared plus 5 to the minus a half times 2x. And as with Mathcar, we know that if we make it look a little tidier, it helps us out as we go along. So I would probably tidy this to recognize that the 2 and the half are going to cancel out. This is traditionally written down the bottom with a square root, and we can probably write this as x over root x squared plus 5. You don't have to, but it's just that little bit nicer. Yeah? It's going to help with our substitutions later on. Now, we want a few things. We want f dash a and f of a, and both of these are numbers. F dash a is us substituting the point of interest into the derivative. So in this case here, you make a little note that that's a, that's the point of interest. We really are here after f dash 2. F dash 2 is 2 over, 4 plus 5 is 9, root 9 is 3, so 2 over 3. Yeah? So, it is worth just tidying as you go because it makes our life easier. That means that the slope of the function at 2 is 2/3. The other thing we need is f of 2. Now, f of 2, they've actually kind of given us here. If we put in 2 to the original function, we're getting out 3. So that 3 there, you can make a little arrow above it and write f of a. Because it's in the formula, but that's a and that's f of a. So f of a is 3. Right, then it's a matter of writing the formula. Y equals f dash a, x take a, plus f of a. It's the formula given on the notebook. You can have it on your note sheet. And we plug in all the numbers where applicable. So y equals f dash a is 2 on 3, bracket x take 2, because that's the a, plus 3. And that is probably what's written in the back of your book as your answer. I would normally simplify it to go a little further because we like seeing a tangent equation in my mind in the form of y equals mx plus c. We like the y on its own, which is good, and then this takes a little bit of tidying. So y is going to equal 2x on 3, or 2/3 x. That is minus 4/3 plus 3. What's 3 minus 4/3?
5/3.
Yeah. That's this combining with that. So that's minus 4/3 plus 3, and 3 is really 9/3. So minus 4/3 plus 9/3 is that 5/3. The other, sorry.
Can you plug in the x value again? Like, at the bottom, and get an actual answer?
Okay, good question. So here, if you were to plug in the x value, you would get y equals 3. Which is neat, because if you put the x value in here, you should get the same y value as if you put it into the original function there, because they're sharing that point. So it's almost a little check you can do to make sure that it is really hitting the right point.
Yep.
But yeah, it wouldn't help you much with getting it. Alright, so that's the formula. You find f dash a, f of a, throw it into formula, you get the thing. The second method, and you can draw a line down your page, is the y equals mx plus c method. And yeah, Dr. Zhao was a big fan of this one. I think most math teachers are more a fan of this because it requires slightly more understanding. You've got two things to hunt here, an m and a c, and the important thing to notice is that this m is the derivative at that point. It's f dash a. So, I would normally start by rewriting the y equals mx plus c once you've found f dash a. We found it over here, so we won't go through it again, but it's y equals 2 on 3 x plus c. Then we need to hunt c, and we hunt c by using a point. We're going to use a f of a. We'll use that point they've given us. Sometimes they'll just give us an x value and you have to find the y value, but in this case they've given it to us. So to hunt this down, we're going to put in the x and y accordingly. 3 equals 2 on 3 lots of 2 plus c. 3 equals 4 on 3 plus c. C equals 5 on 3. And you can sort of see that it's really the same thing coming out here. We're getting to the same place. But this is just a method that you find m first using the derivative, you find c using the point. You may all know to yourself that this is actually a point.
Do we have to refer to the original coordinates as a FA, or can we just use like x and y?
You can use x, y.
Does it ever say in the test that you have to use the formula method, or can you always use the one on the right?
No, you can always use the one on the right. Sometimes they'll say, show that it's in this form.
Yeah.
So for example here, it would be fairly common to see this written as 3y take 2x equals 5 in general form. But if they said show that it's this, and you guys landed here, it wouldn't take a lot of legwork to go from there to there. You know, you're going to have to multiply everything by 3 and drag the 2x over. So sometimes they'll say give your answer in general form, which is that.
Yeah.
But you're right, you won't be required to use the formula. Alright, I wanted to do one normal example and then 2 more examples. So, next page is normal. Oh, I made this one hard, didn't I? Do you guys know what the normal was from last year?
Is it not like the opposite, like it's going through that way instead of...
Perpendicular to the tangent.
Yeah. So, the only difference is, rather the slope being f dash a, is it's minus 1 on f dash a. So, in this case here for the normal, the slope of the line is minus 1 on the derivative of whatever a was. So, there's a formula here. I suggest we do this twice. but I think for time purposes we'll just do it once. Did you guys want to do the mx plus c method or the formula method?
Mx plus c.
mx plus c, cool, we'll aim for that. Alright, so for mx plus c, the first thing we really need is f dash of a. We need this anyway to get us Rn. So, let's find f dash x to start with, and then sub in x. F dash x is minus 2 sine 2x plus 3 cos x. Yeah. So you're probably getting a feel of the idea that for tangent to normals we can pull on any differentiating sort of combination you've done throughout the topic. The second thing that's going to make you slightly uncomfortable is it's probably worth having your unit circle on you. Because this is our next point. This is our A. We're interested in this point here. So we're going to sub in pi on 6 into this formula. So we're now hunting f dash A, which is f dash pi on 6, is equal to minus 2 lots of sine 2 pi on 6, which I know is pi on 3, plus 3 lots of cos of pi on 6. Now, there are really 3 that you're interested in. There's pi on 6, there's pi on 4, and then there's pi on 3. And even if you just include this quarter of the unit circle, it's generally worthwhile because then you can move it to any quarter. So this one here is root 3 on 3, a half. Meaning this is, remember, the cos value, this is the sine value. That is root 3 on 3 across, a half up. This is root 2 on 2, comma, root 2 on 2. And this final one is a half root 3 on 3. All the special triangles, yes?
What were they?
You don't remember them?
Your special triangles need to decide of, like, what is it? 1 and 1, 1 and 2. Well, you can do the special triangles or you can do this. If you want a special triangle, go for it. I can't remember it off the top of my head right now, but this for now. This will do in terms of our substituting. This is pi on 3, so from our little diagram, what was sine of pi on 3?
Root 2 over 2.
Sorry, this is the pi on 3 one.
Root 3 over 3.
Yeah, root 3 on 3. So this is minus 2 lots of root 3 on 3. What's cos of pi on 6 here? Lovely, so it's like 3 lots of root 3 on 3. Now, this is minus 2 root 3 on 3 plus 3 root 3 on 3. Are you happy that's just 1 lot of root 3 on 3? Or maybe I should have written it like that. Minus 2 lots of this thing plus 3 lots of that thing is 1 lot of it.
What radians?
It's not pretty, but that's it.
Is the calculator wrong?
Calculator.
Is it root 3 and 2?
Yeah, it's root 3 on 2 according to the
Is it really?
Yeah.
because it says negative.
I know.
Whose bike is that at Strasbourg?
It's mine. That's how I get here.
I'm coming with that one.
Yeah, so that's a 2, and that's a 2. Therefore, that's a 2, that's a 2. It actually all works out that that's just a 2. Could have been worse. Not great.
And then do you have to flip that?
Yeah, with a negative. So, Rm isn't just this, it's the negative reciprocal of this, meaning it's minus 1 over that. So what Rm is actually is minus 2 on root 3. And now we're getting closer because we're after, at the end of the day, a y equals mx plus c. We're after a line, we found our m. So it is y equals minus 2 on root 3 x plus c. Now we need to find the c. Go over here. To find the c, we sub in a point. We haven't been given a full point, but we're given part of one. We've been given the x coordinate, we need to find the y coordinate. So we need to sub pi on 6 into here and into here. What is sine of pi on 6? A half, yeah. So we're looking for f of pi on 6, which is going to end with 3 halves. And cos of 2 pi on 6, which is cos of a third, is another half, which is going to equal 2. So f of pi on 6 equals 2, because it's like a half plus 3 halves, no, it's 2. That is our xy pair. So I know we're writing it in function notation, but really this is our x and this is our y that can then go back into this. So 2 equals minus 2 on root 3 lots of pi on 6 plus c. I don't see any particular way to simplify that nicely. Huh? Call it a day there. C is just that subtracted off the 2, and therefore our equation is y equals minus 2 on root 3 x plus the mess that is c. So it's not particularly pretty.
Could you use a calculator?
Yeah, but I mean this isn't going to work out so nicely.
So do you just leave it like that?
Yeah. So don't end in decimals wherever you can, end in fractions or pi or
Right,
roots.
would you still have to write the equation out with c?
Yeah. So I'll write it out to save completeness, but it's going to be y equals minus 2 on root 3 x plus 2 plus 2 on root 3 pi on 6. So that's basically that 2 with that added on, because it was a negative, and that's our c. That bit there is this whole c here. It's not pretty, but it's doable. Alright, because we did an ugly one there, the next one is pretty. This one. I've included this as several of you have expressed a joy for A and B values and those style questions. I'll put some more practice on Canvas if you want A and B, but this is a good question. I like it.
16.
Can I get my Mentos 20 out when the camera was off? No. Just to annoy Henry?
No.
A good few Mentos. Camera on, and then
Thank you.
Yeah, actually.
Alright, this one here.
I'll tell you later, alright?
Y equals a root x plus b on root x, where a and b are constants. The normal to this curve at the point where x is 4 is 4x plus y equals 22. Alright. We need 2 equations to find our 2 unknowns. And 2 equations means 2 pieces of information that largely we can get from this. So, are you happy if I rewrite this as y equals minus 4x plus 22? Yeah? Alright. First piece of information is, when x is 4, we can find what y is. So here, if I sub in x is 4, 16 plus y is 22, what's y?
6.
6, good, stay with me. So what this is saying is, really there's this point 4, 6. There is this point where we have some x value, we can call it a, and f of a, which is the point 4, 6. So they've told us a point of interest and the value at that point of interest. I perhaps shouldn't use a because it's already in the question
Where did you
somewhere.
get the 6 from?
I got 6 from putting 4 into there.
Okay.
So the important thing is this normal goes through a common point with the curve. So when I put 4 into here, I know that y will come out as 6. So we can do that for our first equation. When I put 4 into the equation, it must come out as 6, because I know when I put 4 in here, that comes out as 6. So let's put it in there. So then 6 equals 2a plus b on 2.
Why?
Is
Oh.
it 2 root A?
It is, but a was 4. I jumped a step, sorry.
Okay.
So yeah, root 4 is the 2.
Yeah.
And that's also root 4, so hence 2.
Oh, yeah.
Yeah, so both of those 2's are root 4's. One equation. Awesome start.
Dash of A there.
But now we want our second equation. So, first equation we got from having a common point. The second equation we get from the fact that we actually know the slope of the function at this point. So I know that minus 1 on f dash 4, so the negative reciprocal of the slope, is equal to minus 4. Yeah, wait.